I want you to try something for me right now. It doesn't really matter where you are. You could be walking the dog, maybe sitting on the train, or just lying on your couch. I want you to just feel the weight of your own body.
Right.
Feel that pressure against your feet or your back, because that sensation is basically the most constant, undeniable fact of your existence. It's the thing that keeps your coffee in the mug and the atmosphere clinging to the planet. We call it gravity.
It is the invisible glue. I mean, it's the one force you really can't switch off. You can shield yourself from electricity. You can block a magnetic field. But gravity, it is completely relentless. It is everywhere.
Exactly. And because it is so constant, so mundane, we just assume we know what it is. We have these mental models we all learned back in school.
The apple falling from the tree.
Yeah, exactly. You picture Isaac Newton getting bonked on the head by an apple. Or if you've watched a few science documentaries, you picture Einstein's version. A heavy bowling ball sitting on a trampoline, curving the fabric so that little marbles roll toward it.
Right, the old rubber sheet analogy.
Right. We think gravity is a force pulling things together, or we think it's a curve in the actual stuff of space.
And that is the standard narrative. I mean,
Yeah.
it's the story we have been telling ourselves and our students for over 100 years now.
But today, we are going to take that whole story, crumble it up, and basically throw it in the trash. We are doing a deep dive into a stack of recent research papers on a completely new framework. It's called hypergravity.
And the headline here isn't just that we got the math a little bit wrong.
No.
It's not that we missed a decimal point somewhere in the cosmos. The headline from these sources is that we have the entire stage wrong.
It is a fundamental reordering of reality. The sources we are analyzing today argue that gravity isn't a force, it isn't a field. And it definitely isn't even the result of tiny quantum particles, gravitons just bumping into each other.
Right.
The core thesis here is that gravity is, and I'm actually going to quote this directly because it sounds like pure Star Trek technobabble at first glance.
It really does.
It says gravity is an invariant constraint on coherence gradients at a pre-geometric level.
Which, I freely admit, sounds like something you say to win a very nerdy Scrabble game, not to explain why you fall down when you trip over a curb.
It absolutely does. But that is our mission for this deep dive. By the time we wrap up today, that insane sentence is going to make perfect sense to you.
Hopefully.
It will. And it is going to make you look at the empty space right in front of your face very, very differently. Because this theory suggests that space and time aren't the stage the universe acts upon. They are the audience. Or maybe just the program bill they hand out at the door.
We're essentially asking a huge question here. What if the map isn't just different from the territory? What if there's no territory at all, at least in the way we understand it? What if the literal ground beneath our feet is just a shadow of something so much more complex?
So buckle up. We are going to tackle the status problem. In modern physics, we are going to learn why searching for gravitons might be the single biggest wild goose chase in scientific history, and we're going to try and visualize what happens before geometry even exists.
Let's get right into it.
Let's start with the beef, the major conflict. Why do we even need a new theory to begin with? Because I thought Einstein nailed this back in 1915. General relativity is the absolute gold standard, right? We use it to calibrate our GPS satellites.
We do.
It predicted black holes decades before we ever actually managed to take a picture of one. It works.
It works beautifully. And honestly, that is the tricky part. General relativity, or GR, as we usually call it in the field, is incredibly successful at describing the effect of gravity.
Effect.
Right, yes. If you want to know exactly how a planet moves around a star, or precisely how light bends around a distant galaxy, Einstein gives you the absolute perfect equation for that. But there is a massive stalemate in modern physics right now. It's essentially a Cold War.
A stalemate between who?
Between the two giants of the 20th century. Classical general relativity on one side and quantum mechanics on the other.
Ah, the Hatfields and the McCoys of physics. They just do not get along.
They really don't. And here is the core of their fight, as outlined in our source material. Classical general relativity, Team Einstein, treats curvature as a primitive structure.
Okay, wait. When you say primitive, you don't mean like simple or crude, right? Like a caveman tool.
No. In philosophy and in theoretical physics, primitive means fundamental. It means it is the absolute baseline. You can't break it down any further.
Okay, got it.
Einstein's theory basically assumes that the stage of space-time exists fundamentally. It assumes there is this smooth, continuous fabric everywhere, and matter just tells that fabric how to bend. The fabric itself is the baseline reality.
Okay, so Team Einstein says the stage is real, it's totally smooth, and it bends when heavy stuff sits on it. What does Team Quantum say?
Well, quantum gravity researchers look at that smooth stage and they say, no, that's completely impossible. Because in the quantum world, nothing in the universe is smooth.
Everything is pixelated.
Exactly. Everything is made of chunks. Energy comes in discrete chunks, light comes in chunks, photons. So they naturally assume that space-time itself must also be made of chunks.
So they are actively trying to quantize the stage.
They're trying to break the stage down into microscopic parts. They're desperately looking for space-time atoms, or these theoretical particles called gravitons, that somehow carry the force of gravity between objects.
They're looking for the sawdust that makes up the floorboards of the universe.
That is a fantastic analogy. Yes. Einstein says the floor is a single, perfectly smooth sheet of rubber. Quantum mechanics says the floor has to be made of sawdust.
And this is exactly where our source material comes in with a massive sledgehammer, because it argues that both sides are just flat out wrong.
Well, not just wrong. The authors argue that both sides are making a profound category error.
A category error, which is really just a very polite academic way of saying, you aren't even asking the right question, guys.
It really is. The primary argument across these papers is that both classical physics and quantum physics are trying to explain the origin of geometry by presupposing that geometry already exists.
Wait, let me break that down. How do you try to explain geometry by assuming it exists?
Well, think about it. Einstein says geometry curves.
Right.
The quantum guys say geometry is made of particles.
Oh, okay.
Both of those statements assume that geometry, meaning distance, length, time, the very concept of here and there, is the actual thing doing the work. They assume the stage is the physical object we need to be studying.
They are totally obsessed with the container.
Yes, they are obsessed with the container. But the sources we are looking at today argue that curvature isn't the container at all. It's an emergent descriptor. It is just a bookkeeping tool.
Bookkeeping. I have to say, that is not a word I generally associate with galaxies colliding or massive stars exploding.
It might not sound glamorous, but it is the perfect word. Imagine you were looking at your bank statement. You see a number on there? Minus $50. Now, that number is real, right? It affects your life. If that number goes too low, you can't buy food.
Sadly, yes.
But can you take that debt and put it under a microscope?
Yeah.
Can you isolate the atoms of that $50 transaction?
No, of course not. The statement is just a record. It's just a digital or paper record of a relationship between me and, say, the restaurant where I bought dinner.
Exactly. The source argues that trying to find the quantum particle of gravity, the graviton, is literally like looking at the ink on your bank statement and trying to find the physical atoms of value. You're looking at the record of the event, not the transaction itself.
Wow, that is a massive claim. That is essentially telling thousands of brilliant physicists working in string theory and loop quantum gravity that they have been studying the ink instead of the money for the last 50 years.
It is an incredibly bold stance, but you have to admit, it elegantly solves the stalemate. If geometry isn't the fundamental thing, then we don't need to force it to be smooth or force it to be chunky.
Yep.
We need to look at what creates the record in the first place.
We need to look upstream.
Exactly. We need to look at the underlying process that actually generates the bank statement. And that brings us to the real core of this framework. The source material proposes that there are two distinct levels of reality, the continuum and the closure.
Continuum versus closure. Honestly, this sounds like the title of a sci-fi novel. Let's start with the before state. The text calls this continuum ontology, or CO for short.
Right, CO. This is the upstream level of reality. This is the state of the universe before geometry even exists.
I have to stop you there. Before geometry exists, how can physics, or anything at all, exist without distance? If I'm not here and you're not there, where are we? How can there even be a we?
This is genuinely the hardest mental hurdle to get over with this theory. Our brains are biologically evolved to hunt mammoths in 3D space.
Yeah, we like our coordinates.
We are completely wired for coordinates. We think exclusively in terms of X, Y, and Z axes. But the text asks us to imagine a structured phase space instead.
A phase space. Now, that's a term from thermodynamics, right? Like a menu of all possible options or states a system could take.
Yes, exactly. In this continuum state, this CO level, there is absolutely no metric geometry.
And no metric just means no ruler.
No ruler, no inches, no seconds, no left, no right. There is no material reference whatsoever.
So is it just a void? Like total nothingness?
No, it is emphatically not a void.
Yeah.
Because a void implies an empty space just waiting to be filled with stuff.
Hmm?
If you have an empty box, you still have the box.
Okay, good point.
This is entirely different. This is a state of distinct structured potential. The text describes it as a space of admissible coherence modulation.
Okay, we are definitely going to need to unpack admissible coherence modulation before my brain just melts completely out of my ears.
Fair enough. Let's use an analogy to ground this. Think of a massive choir.
A choir. Okay, I'm picturing it.
Imagine 1,000 singers standing in a completely pitch-black room. They haven't started singing a specific song yet. They're just warming up.
Just humming, maybe adjusting their pitch.
Right. There is this massive potential for harmony.
Okay, I can visualize that.
In physics, we call these potentials eigenmodes. These are the natural patterns of harmony that the system could theoretically fall into.
The options on the menu.
Yes.
Mm.
In this continuum state, the choir isn't singing a specific note at a specific time. They're in a state of flux, constantly shifting between these potentials. They are cohering, meaning they are connecting, they are relating to each other, but not in any fixed, measurable way yet.
So it's almost like the raw ingredients of connection.
Yes, the raw capacity for relationship. And the source mentions deformation at this level. But because there is no space yet, it isn't physical stretching like you would stretch a rubber band.
What is it then?
It is the variation of these coherence modes along anisotropic directions.
Anisotropic, that just means direction matters, right? Like how wood grain has a specific direction, it's way easier to split a log along the grain than against it.
That's a great way to put it. So in this pre-geometric soup, you have these gradients of coherence, these patterns of relationship, intensity shifting and changing. But they haven't locked in yet.
Right.
There is literally no physical distance between the singers because they haven't actually taken their assigned seats on the stage yet. They are just voices in the dark.
Voices in the dark. That is actually quite poetic for a physics paper.
It is.
So that is the continuum, the soup, the before. Then comes the major transition. The source calls this atomic ontology closure, or AO closure.
This is the critical moment in the theory. Closure is when that fuzzy, shifting, undefined continuum becomes a distinct physical reality. It is the exact moment the potential becomes actual.
The moment the choir finally sits down in their chairs and just belts out the first chord of the actual song.
Yes. The coherence modulation becomes bounded, it gets discretized and localized.
Discretized meaning chopped into discrete bits, right?
Uh-huh.
It becomes countable.
Right, it becomes distinct and separate. And localized means it now finally has a position relative to other things.
And this right here is where the huge aha moment happens in the text. Because it says distance and angle only become meaningful after this closure event happens.
Precisely. You literally cannot measure the distance between 2 points until those points have been rigidly defined and locked into a stable relationship. The source uses a really crucial philosophical distinction here. It distinguishes between mathematical well-posedness and ontological realization.
That sounds extremely heavy. Translate that for us mortals.
Mathematical well-posedness just means the potential for the structure exists perfectly in the math.
Okay.
Think of a game of chess. The abstract rules of chess exist whether you are playing or not. You know exactly how the knight is allowed to move. You know how the bishop moves.
Right, the framework is there.
But the game itself hasn't started yet. Ontological realization, on the other hand, means the physical board is completely set up, the wooden pieces are resting on the squares, and the game is actively being played in reality.
Oh, I see. So the continuum is the rule book. The closure is the actual game being played on the table.
Exactly. And you obviously can't measure the physical distance between the king and the queen until the actual wooden board appears in front of you.
That makes total sense. You can't measure the physical distance between two abstract ideas. You can only measure the distance between two realized concrete things.
Precisely. And once the game starts, once closure finally happens, suddenly we have a metric. We have geometry. We have a definitive here and there. But those concepts actively emerge from the closure process. They didn't exist a millisecond before it.
This naturally brings us to the actual title of this deep dive, hypergravity. We have established pretty firmly that in this new view, gravity isn't a force pulling apples down from branches. So what is it?
Hypergravity is defined in the paper as the invariant constraint.
Constraint. That implies a limitation of some kind, a boundary or a strict rule.
Exactly, and it operates exclusively at that continuum level, the pre-geometry level we were just talking about.
So hypergravity is the thing that is telling the pre-geometric coherence soup how it is actually allowed to swirl.
That is a very good way to put it. It rigidly restricts how the coherence gradients can be ordered. It doesn't tell matter how to move, because again, matter doesn't even exist yet.
Right.
It doesn't tell space how to curve, because space doesn't exist yet either. It purely dictates the structural conditions that must be met.
It is the architect, not the builder.
Yes. Think of it like a sieve or a strict filter. Hypergravity is the set of fundamental constraints that says if you're going to form a physical reality, it absolutely has to have this specific kind of coherent structure.
It's setting the ground rules.
Exactly. It isn't a force pushing you down. It is a filter that only lets certain mathematical realities pop into existence.
Let's explicitly compare this to conventional gravity, just so we are crystal clear on the difference. In the old way, Einstein's way, gravity is geometry, space curves, and things fall along those curves.
Correct. In the traditional Einstein view, curvature is the primitive structure. It is the fundamental thing doing the heavy lifting. But in this new framework, curvature is strictly at the AO level, the realized level. It is merely an emergent descriptor.
And hypergravity is upstream of all of that.
Hypergravity is anchored at the CO level, the continuum. Its official status is invariant constraint. Its role is completely prior to geometry.
So if I'm tracking this right, hypergravity is the boss making the big decisions. Curvature is just the mid-level employee filling out the TPS reports after the fact.
That leads us directly into the bookkeeping concept, which I personally find absolutely fascinating. This is section 3 of our breakdown. The source explicitly calls space-time curvature a geometric shadow.
I really loved that phrase when I was reading the materials. A geometric shadow. Because a shadow isn't a physical object, is it? You can't pick up a shadow, you can't weigh it, but it absolutely tells you something true about the physical object casting it.
The mechanism of emergence here is described as a very specific 3-step process in the text. We really need to walk through this sequentially to get a grip on it.
Okay, let's do it. Step 1.
First is the constraint. That is, hypergravity actively restricting the admissible coherence distributions in the premetric soup.
The rules of the choir. You are only allowed to sing in the key of C.
Exactly. Step 2 is localization. This is the AO closure event. The fuzzy system locks down hard. It instantly becomes a closed domain. Now, and only now, you can compare point A to point B.
The choir finally takes their assigned seats. The physical structure is fixed in place.
And then comes step 3, representation. This is where the curvature tensor, which is the extremely complex math of Einstein's gravity, finally appears. The source argues that curvature emerges simply because it is the only mathematical way to represent spatially inhomogeneous coherence responses.
Okay, spatially inhomogeneous coherence responses. That is a serious mouthful. Let me try to translate that into plain English.
Please do.
When the system locks down into reality, the coherence, meaning the underlying relationships, they aren't perfectly smooth and even everywhere.
Right.
Some places in the universe are tighter or much denser in terms of that pre-geometric connection than other places.
Yes. Imagine a massive fishing net laid out on a dock. If you grab a handful of that net and bunch it up tightly into a knot in one spot, the little squares around it get totally distorted.
Yeah, they get much smaller and tighter inside the knot, and they get stretched way out further away from the knot.
And to describe that visual distortion,
yes,
we use the language of geometry. We'd look at it and say, oh, the net is curved.
Exactly. But, and I think this is the absolute crucial part of the whole theory, the net isn't actually bending downward because a heavy bowling ball is sitting on top of it. The curve we see is just a visual record of the fact that the underlying coherence is bunched up in that specific spot.
It is entirely a bookkeeping tool.
Wow.
It just records how those pre-geometric coherence gradients happen to organize themselves within that newly closed domain. The text is very explicit here. It says geometry is not the substrate, it is the trace.
The trace, like footprints in the snow. The footprints aren't the person walking, they are just the physical record that someone walked there recently.
And this simple realization explains exactly why we have been so incredibly confused as a scientific community for the last century. We have been staring at the footprints, the geometry, and spending billions of dollars trying to figure out what quantum particles the footprints are made of instead of looking up and searching for the walker.
So I have to play devil's advocate here for a second, because every time we do a deep dive into fringe or cutting-edge physics, we eventually have to ask, does this mean Einstein was wrong? I feel like we always end up defending Einstein, but this really sounds like it is saying his whole curved space idea is just a grand illusion.
The source material is very, very careful on this exact point. It is absolutely not saying Einstein was wrong in his practical calculations.
Okay, good. The GPS satellites aren't going to crash.
The GPS satellites still work perfectly. Black holes still exist and behave as expected. It says the math of general relativity is completely preserved. Einstein's field equations are still 100% correct.
The equations work flawlessly, but we have just been interpreting what they mean completely wrong.
Exactly. The source reclassifies Einstein's equations. It calls them effective relations governing closed domains.
Effective relations. That sounds a lot like saying they are just incredibly accurate rules of thumb.
It means they perfectly describe the macroscopic organization that results from AO closure. They describe the shape of the shadow perfectly, but they don't describe what is casting the shadow.
Okay, let's take the stress energy tensor as an example.
Great example.
In Einstein's standard theory, this is the matter, the planet, the star, the gas cloud that actively tells space how to curve. The classic quote is, matter tells space how to curve, space tells matter how to move.
Right. It is a strictly causal relationship. The heavy planet physically causes the rubber sheet to curve downward.
In this new hypergravity view, what exactly is the planet then?
In this new view, the stress energy tensor isn't a causal source at all. It doesn't push on anything. It simply parameterizes the effective distribution of coherence realization.
It parameterizes the distribution. So instead of the planet being a heavy, dense object pushing down on the fabric of space, the planet is really
What?
just a really big knot in the coherence net.
Fundamentally, yes. The presence of what we call matter is merely a region where the pre-geometric coherence has locked down in a highly dense, energetic configuration.
Wow.
The curvature we measure is just the neat mathematical way we describe that extreme density relative to the empty space around it.
This totally explains why general relativity works so incredibly well for black holes and large-scale cosmology. It is what the paper calls operationally valid.
Operational validity, yes, that is the exact term. It works flawlessly because the geometry faithfully records the final outcome. If I log in and check my bank statement, it faithfully records that I just spent $50 on dinner. The statement is valid. It is entirely true.
But the bank statement didn't literally cook your dinner.
Exactly. Einstein wrote the absolute perfect code to read the bank statement, but he didn't write the code for the economy itself.
That is a fantastic analogy. And honestly, this brings us right back to the bitter fight with quantum gravity. Because if Einstein basically wrote the code for reading the bank statement, the quantum gravity researchers are trying to use that exact same code to find the physical atoms of the economy.
And the source document calls current quantum gravity research conceptually misplaced.
Conceptually misplaced, which is the most polite, utterly devastating academic speak for, you are completely wasting your entire career.
It is a profoundly strong critique, but based on the logic of this framework, it is a completely necessary one. The source argues that these brilliant scientists are all trying to quantize the descriptor.
Quantize the descriptor, meaning they are trying to chop up the bookkeeping tool itself into little quantum bits.
Right. They're actively trying to quantize curvature. They want to find the ultimate pixel of geometry. But if geometry is really just a shadow or a ledger entry, it inherently doesn't have pixels in the way a physical piece of matter does.
We mentioned the ledger analogy earlier. The outline we are following literally says, trying to reconstruct a transaction by analyzing the ink on the ledger rather than the exchange of goods.
Yes. You can put that ledger under an electron microscope and zoom in on the ink until you clearly see the individual molecules of the pigment. You can count the carbon atoms in the ink,
Sure.
but counting those carbon atoms will never, ever tell you why I bought the dinner. It won't tell you the subjective value of the meal.
So searching for gravitons, the hypothetical quantum particle that supposedly carries gravity, is exactly like searching for the fundamental ink molecule of a financial transaction.
According to this framework, yes, absolutely. It is a massive category error. You are mistakenly applying the rules of matter, which is quantization, to the rules of the record, which is geometry.
So if you actually want to quantize something, and the source does admit that quantization is probably necessary at some level, you have to go upstream.
You have to target the raw dynamics of the coherence eigenmodes themselves. You have to look at exactly how the choir is harmonizing in the dark before they sit down in their chairs. You have to quantize the pre-geometric soup, not the resulting space that emerges from it.
But wait, I have a major question here.
Go for it.
If quantum gravity has been looking in the completely wrong place for decades, why hasn't it just failed completely? Why do these theories like string theory or loop quantum gravity, why do they persist year after year? Why are there thousands of peer-reviewed papers still being written on them?
Because of a concept the source calls the persistence of geometry. It explains that even if you mathematically mess around with the quantum details at the absolute smallest scales, the closure mechanism itself usually stays completely intact.
So the closure is robust, it's hard to break.
Extremely robust. The shadow looks basically the same whether the physical object casting it is made of carved wood or solid steel, as long as the outward shape is the exact same.
Hmm.
Geometry is a highly robust description. It easily survives in what physicists call semi-classical regimes.
So the ledger remains accurate. Even if you write the numbers with a blue pen instead of a black pen, the math still adds up at the end of the day.
Exactly. Until it doesn't. And this is where we get to the really fun mind-bending stuff, the breakdowns.
Yes. Section 6, singularities. Now, in standard textbook physics, a singularity like the infinitely dense center of a black hole or the exact moment of the Big Bang is a total nightmare.
It is the bane of a physicist's existence.
It is a point of infinite density. The math literally outputs an infinity, and physicists universally hate infinities. It usually means your theory has just catastrophically failed.
Right. It is traditionally viewed as a physical infinity, like
Yeah.
the fabric of reality actually tears open or an object becomes literally infinitely heavy. But the hypergravity framework completely redefines what a singularity is.
How so? Because getting rid of infinities would be a huge win.
It says a singularity is not a physical infinity at all. It is simply the specific point where AO closure fails.
Closure fails, the lockdown just breaks.
Yes. The domain is literally no longer closed. The bookkeeping tool geometry abruptly stops working because the system in that extreme region has forcefully reverted back to the premetric continuum.
Oh, wow. So inside the core of a black hole, or right at the singularity, it isn't that gravity just gets infinitely impossibly strong. It is that the very concepts of place and time stop existing as valid descriptors.
It is a representational breakdown. The map dissolves entirely. You are thrust right back into the pre-geometric soup.
Yeah.
The coherence is no longer bounded or localized.
It makes so much intuitive sense. We have been stubbornly trying to use the map to describe a place where the map fundamentally does not apply.
Imagine you are drawing an old-school map of the world on a flat piece of paper on your desk. You keep drawing, and eventually you get to the edge of the paper. Your pen slips and falls off the table.
And that edge is the singularity.
Right. Is the real world infinite right there at the edge of your desk? Does the actual planet end where your paper ends?
No, of course not. You just ran out of paper.
Exactly. The representational tool, the physical paper, failed you. But the reality continues in a way the paper can no longer capture.
This also seamlessly solves another huge headache in theoretical physics that was mentioned in the sources, the local energy density problem. Now, I am not super familiar with this one, to be honest. What exactly is it?
Well, in standard electromagnetism, it's pretty straightforward.
Yeah.
You can point to a space and say there is exactly this much energy right here in this 1 cubic inch of the electric field. You can perfectly localize the energy.
Okay.
But in general relativity, it is notoriously difficult. And some prominent physicists argue it's actually impossible to define the local energy density of the gravitational field itself. You simply cannot point to a specific coordinate and say the gravity energy is sitting right here.
Why not? That seems like a glaring flaw.
In the standard view, it is a massive unresolved mystery. It's a thorn in everyone's side. But in the hypergravity view, the answer is blatantly obvious. Gravity isn't an interaction taking place within the geometry. It is the constraint acting upon the geometry's formation.
Oh, I see. You can't find the energy inside the box if the energy is actually the mathematical rule that constructed the box in the first place.
Exactly. It is another massive category error. You are desperately looking for the carpenter hiding inside the wooden cabinet he just built. The carpenter isn't inside the cabinet. He is entirely outside of it, defining its outward shape.
This is, honestly, it is incredibly elegant. It takes all these massive historical paradoxes, singularities, local energy density, the century-long clash between quantum and classical mechanics, and it just cleanly sidesteps all of them by simply saying, you guys are all looking at the wrong layer of reality.
It is a monumental shift in perspective.
Yeah.
And that is exactly what Section 7 of our deep dive is all about, the broader implications.
The source text spends some time talking about regimes of validity, basically knowing exactly when to confidently use the map and when to recognize you need to put it away.
Yes. This theory confidently predicts that geometry, meaning standard Einsteinian general relativity, will remain incredibly accurate wherever the closure is stable and homogeneous.
So basically in most of the observable universe, weak gravitational fields, solar systems, typical galaxies, the closure holds strong there, so the standard map works fine.
Correct. We should really only expect to see major deviations from Einstein's predictions in places where the closure physically changes character. Extreme boundaries.
Not just environments with really high energies, but specific boundary conditions.
Right, and this is a really subtle, nuanced point. Usually, physicists automatically think small scale automatically equals quantum physics, so gravity must act weird there.
Right, the microscopic level.
But this framework suggests that even at incredibly small scales, if the closure mechanism remains stable, classical geometry might still work perfectly fine. But if you look at the event horizon of a black hole, or the exact moment of the Big Bang where the closure itself is dynamically forming or actively breaking apart, that is exactly where we will finally see fundamentally new physics.
It is the ultimate geometry as trace philosophy.
It fundamentally changes what we even think the laws of physics actually are. We typically think of laws as being universally, fundamentally true everywhere. But here, the laws of geometry are really just the localized result of parameter openness.
Parameter openness. Break that down.
It just means the underlying pre-geometric continuum has the potential to mathematically close in many different ways. But once it actually does close, it is forced to follow strict geometric rules. Universality is a feature of the closure event, not the underlying substrate.
So the laws of physics look beautifully universal to us just because the closure event happened the exact same way everywhere in our specific universe. But underlying all of that, the pre-metric soup could have potentially organized entirely differently.
Potentially, yes.
Yeah.
And it resolves all this philosophical tension without needing to invent some magical, elastic space-time fabric. We don't need space to be a literal material that stretches and warps. And we definitely don't need hypothetical gravitons endlessly flying around communicating gravitational force between planets.
No, we just need three things: coherence, constraints, and closure.
It radically simplifies the basic ontology of the universe. It perfectly follows Occam's razor. Do not multiply entities beyond necessity. If you don't need a graviton, don't invent one.
So let's try to bring this all home for the listener. The big so what of it all. We have spent an hour talking about ledgers and shadows and pre-geometric soups. But what does this actually mean for the immediate future of science?
It means we desperately need to stop trying to repair the geometry.
We have been spending decades trying to patch the tiny holes in the map.
Exactly. We have been agonizing over fixing the singularities, trying all sorts of mathematical tricks to smooth out the infinities. This framework forcefully suggests those holes are supposed to be there. They are the glass windows looking down into the deeper fundamental reality.
The whole mission of physics shifts from fixing the geometry to mathematically modeling the pre-metric chaos.
We need to dedicate our resources to understanding the raw dynamics of the continuum. How does raw coherence naturally organize itself? What are the precise mathematical rules of hypergravity that force the closure event to happen? That is the real new frontier.
It honestly feels like we are standing at the edge of a flat Earth, realizing for the very first time that it is actually a globe. Or maybe realizing that the Earth isn't the ground at all, but the sky.
Or that the solid ground was really just a massive collective agreement we all unconsciously made to stand perfectly still.
To quickly recap for our listeners, because we have covered a massive amount of ground today, or I guess non-ground.
Non-ground.
1. Continuum ontology. Reality starts as a swirling phase space soup of coherence with absolutely no distance or time. 2. Hypergravity. The strict invariant rules, the constraints that order the swirling soup. 3. Atomic ontology closure. The soup suddenly freezes and locks into a specific localized structure. And 4. Curvature. The measurable geometry finally appears. It is merely a shadow, a record, a bookkeeping tool of that locked-in structure.
And 5. The mistake. We have spent a century trying to chop up the shadow to find the physical object.
There's a quote from the source I want to read. It says, "Gravity is neither eliminated nor elevated. It is placed. Curvature emerges not because space-time bends, but because coherence closes."
It is a genuinely beautiful thought. It makes the entire universe feel, I don't know, less mechanical, less like a cold clockwork machine, and much more like a continuous process, a constant state of becoming.
It definitely leaves me with one massive burning question, and I want to leave you, the listener, with this thought to mull over too. If space-time is really just a shadow, and hypergravity is the abstract light casting it, what is the actual object? What is the fundamental thing that is actually cohering? If we strip away space, and we strip away time, and we strip away all distance, what is actually left of us?
That really is the ultimate question, isn't it? If we are not fundamentally located in physical space, what are we? Perhaps we're all just resonant nodes in that underlying coherence.
Just a little knot of harmony in a choir singing in the dark. I genuinely love that.
It is certainly a lot better than just being a heavy bowling ball sitting on a rubber sheet.
Amen to that. Thank you for diving deep with us today. This one was a serious brain stretcher, but I think we are all a little smarter for having wrestled with it.
It was an absolute pleasure.
Keep looking up, or I guess based on today, keep looking in.
Look upstream.
Look upstream. We will see you next time on another deep dive.